Let us take a problem on vector differentiation. A particle moves along a curve whose position vector is given by r is equal to xi plus yj plus zk, and the parametric equations for x, y, z are given by x is equal to t square, y is equal to t, z is equal to 2t. Find the velocity, acceleration, component of velocity in the direction of a vector p is equal to 2i plus 3j plus k. This is the problem. Now, let us take the position vector. Position vector is r is equal to xi plus yj plus zk. This is the position vector. Now let us substitute for x. What is the x? T square. X is equal to t square. I have substituted t square into I plus y. What is the value of y? Y is equal to t. T into j plus z. What is the value of z? 2t. 2t into k. So what is the position vector? Xi plus yj plus zk. X is equal to t square. Y is equal to t. Z is equal to 2t. You are substituting. Now what you are doing? You are just differentiating this. Right? How to differentiate? With respect to t. With respect to t, if I differentiate, t square differentiation 2t into I. Differentiation of t 1. Differentiation of x squared 2x. Similarly, differentiation of t squared 2t. 2t into I. Differentiation of t 1. 1 into j. Right? Plus differentiation of 2t 2 into differentiation. Suppose if you have 2x, what is differentiation of 2x? 2. Similarly, differentiation of 2t is 2. So this is dr by dt. Now d squared r by dt squared. That means again you are differentiating this dr by dt. So d squared r by dt squared is 2 into differentiation of t 1 I plus j, right? J coefficient is 1, differentiation of that 1 is 0. Now this is 2, differentiation of that 2 is 2k, differentiation of 2 it is 0. So d squared r by dt squared you are getting that to be 2i, right? Now what is the next question? Find the component of velocity in the direction of a vector p. Note the point, component of velocity in the direction of the vector p is given by, observe, component of velocity, so you are writing v dot. I repeat, component of velocity, you are writing v dot. Suppose component of acceleration vector, then you are writing a dot. Remember, so component of velocity v dot in the direction of the vector p, so v dot, I repeat, component of velocity v dot is dot in the direction of the vector p, so v dot p divided by absolute value of p. Now what is the vector p? The vector p is given to be, what is the vector p? 2i plus 3j plus k. Let us write that. P is equal to, the vector p is 2i plus 3j plus k. So sir, vector p is 2i plus 3j plus k. So now absolute value of p means, absolute value of p means square root of, take coefficient of I 2, square it, coefficient of j 3, square that, coefficient of k 1, square that, 1 square. So absolute value of p means square root of 2 squared 4, 3 squared 9. So 9 plus 4 13, 13 plus 1 14. So root 14. So p by absolute value of p. P is 2i plus 3j plus 4k. Absolute value of p is root 14. So let us substitute. So p is equal to v. What is the velocity vector v? V is, observe, dr by dt. So what is v? V is equal to dr by dt. 2ti plus j plus 2k. 2ti plus j plus 2k. This is the, what is that? Component of velocity in the direction of p. It is equal to, right? Component of velocity in the direction of p. It is equal to v dot p by absolute value of p. For v I am substituting. What is v? 2ti plus j plus 2k, that I have written, dot p by absolute value of p. What is the value of p? 2i, right, plus 3j plus k divided by, what is p? 2i plus 3j plus k, that is divided by absolute value of p, root 14. Root 14. Now I have to take the dot product. You know how to take the dot product, it is very easy, right? Multiply the corresponding coefficients of I. What is coefficient of I? 2t. Here what is coefficient of I? 2 by root 14. 2 by, or otherwise do one thing, take this 1 by root 14 outside. 1 by root 14, let us take it outside. 1 by root 14 is taken outside. Now what is coefficient of I? 2t. Multiply that with coefficient of I, 2, plus what is coefficient of j? 1. Multiply with coefficient of j, 3. Coefficient of j is 1. Here coefficient of j is 3. Multiply. Coefficient of k, 2. Here what is coefficient of k? 1. So this is the component of velocity in the direction of the vector p. Okay, let us stop at this.